Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is lexicographically smallest equivalent string. Now, the problem category is of medium level, but I would say this is actually a very easy problem if you know about the algorithm union find. Now, I am going to tell you about this algorithm in detail, and this is actually a very easy algorithm to understand. So now let us see what's there in the question. So the given input in the problem is two strings s1 and s2 of same length, and there is another third string which is base str. So basically you are given total 3 strings, 2 strings who has equal length s1 and s2, and there is another string which is base str. What you need to output is you need to find lexicographically smallest equivalent string of base str. So basically you need to do some conversion in this base str string, and you need to convert it to find the lexicographically smallest equivalent string representation of this base str. Now how can you do this conversion? It depends upon some rules. What you need to do is you need to make use of s1 and s2 which are of equal length. Equal length means they will have same indexes. That is, if they have the length of 5 and 5, then they will have indexes of 0, 1, 2, 3 and 4. Both strings will have the same indexes, right? So we need to make use of s1 and s2, and what we need to do is we need to make groups of characters. So basically a group can be a comma c comma a. This can be one group. Now how can you form a group? It depends upon the s1 and s2. What you need to do is at the same index in both the string, you need to see what are the characters, and you need to form the group of those characters. Now if you are confused with the statement, let me show you what I mean. Let us say at any given index I in both the string s1 and s2, the values are a and a. It means that a and a belongs to one group. Now a and a are same character, so I can say okay, there is a group which has a character a. Now there might be a condition that at the same index I, in s1 the value is a, in s2 the value is b, or in s1 the value is b and s2 the value is a. It means that a and b belongs to the same group. Basically you need to form the group of those characters which are at the same index in both the strings. So for example, if they are a and a, there will be a group which has one element a. If that is a and b, then there will be a group which has elements as a comma b. Even if it is b and a, b in s1, a in s2, there will be a group which will have a comma b as the values, or you can say there is a group which has b comma a as the values. There might be another condition that at any given index, let us say at index 2, in s1 the value is a, in s2 the value is b. So there is going to be a group which has a and b in it. And then let us say at index 4, in s1 the value is b, in s2 the value is c. So there is going to be a group b comma c. But since you can see b belongs to this group and c belongs to this group, there will be just one group which will have a, b and c. So it's like saying that if a and b are in the same group, b and c are in the same group, then basically they all are in the same group. So it's like saying that we have a group a comma b comma c, right? Now let us try to understand how can you solve this particular problem using these groups. Let us understand it using an example in which the given s1 is parker, a string Parker which has total length 6, that is the indexes are going to be 0, 1, 2, 3, 4 and 5. And the s2 string is Morris, Morris, the length is 6 and the indexes are 0, 1, 2, 3, 4 and 5. Let us say the base str is parser, parser. Now it doesn't matter what is the length of this base str, only the length of s1 and s2 will be same. The length of base str might be same as s1 and s2 or may not be. It doesn't matter for the question. Now what we need to do is we need to form groups, right? So this is s1, this is s2. We need to compare the characters at the same index. The indexes are 0, 1, 2, 3, 4 and 5. At the same index we have p and m, right? P and m are at the same index, which is index 0, so they will belong to the same group, right? At index 1 we have a and 0, so we will have another group with a and 0 as the elements. At index 2 we have r and r, right? So we will have a group which is going to have one element r. You can ignore these characters for now, you can just focus on this. We have a group which has one element r. Now let us process the index 3. At the index 3 we have k and r. So we will say okay, k and r belongs to the same group. There is already a group in which there is one element which is r. Let's add k in that group and we will have r and k in the same group. Then we have at index 4 e and i. E and I will belong to the same group. And then we have at index 5 r and s. So r and s are going to belong to the same group. There is already a group in which we have r. So we are just going to add this s into the same group. And now we have this group r, k and s. Now once we have these groups available, what we need to do is from each of the group we need to find what's the lowest character or what's the smallest character lexicographically, and that's what the question is. The question is lexicographically smallest equivalent string. Once you form these groups, you need to find what is the smallest, lexicographically smallest character. In this group, we have P and M. The smaller is M. In this group, the smallest character is K. In this group, the smallest character is A because this is O. And in this group, the smallest character is E. Now what you need to do is, you need to convert your base str, right? You see the output which we need to give is the lexicographically smallest representation of the string base str. So we need to do the conversion in base str, which is parser right now, P-A-R-S-E-R. Now we need to replace each character in this particular string with some other character. Now P will be replaced with M, and why? Because P belongs to this group, and for this group the smallest character is M. So we are going to say P will be M. A is converted to A because A belongs to this group and the smallest character in this group is A. R is converted to K. S is converted to K because R and S belongs to this group and the smallest character in this group is K. Then we have E, which is converted to E because E belongs to this group and the smallest character in this group is E. And then again R is converted to K. So the output for this particular input is going to be M-A-K-K-E-K. This is the example number 1 in the question. Now, once you understand the concept of this question, we need to focus on the solution approach. But first of all, we need to understand what is the intuition or what is the thought process to solve this particular problem. I told you in the start of this video that the algorithm to solve this particular problem is union find. Now you need to understand the pattern of this particular problem. What we need to do. See, the thing is, if we have these groups, it is very easy to convert the base str to this particular string, right? Because once we have the group, in every group, you can just find out what is the lowest character, right? And then you can just run a simple loop in your base str and convert each character in its lexicographically smallest. Now this is fine. But the main thing is, how can you form the group? Let us say you form a group, and in this particular group, this is the smallest character. In this group, this one. In this group, this one. And in this group, this is the smallest character. Now this is a one-to-one mapping. You have a key, which is a group. You have a value, which is the smallest character, right? Now the thing is, let us say, if I ask you, if these are the groups, for P, how can you find the value of M? What you will actually do is, you will run a loop in each of the group to see P belongs to which of this particular group. And once you are able to find out, okay, P belongs to this particular group, then you can find out, okay, what's the value? The value is M. Let us replace P with M. Even if you have the group, you will have to just run a loop in your groups to find out which particular group your current character belongs to. Now this is not the perfect way to do it, even if you have the groups. So we need to focus on creating this group in such a way that for each character, I can find out which group this particular character belongs to, or what's the output or what's the converted character of this character, right? If I am able to find out in optimal way, then this is going to be good, right? So we need to do two tasks. We need to make groups and we need to find out who is the leader or who is the output of that group, right? And this is exactly what this particular union find algorithm do. It can merge common data together, and for every group it will have a leader, and that's something what we need to do. Let us see the example. This is the example, right? We have E and M, A and O, R and R, K and R, E and I, R and S. What we can do is we can merge the common data. P and M are the common data, right? They are in this common group. So these are the common data. These are the common data. Basically, the common group. So what we need to do is we need to form common groups out of it, right? And now for each of the group, there is an output which we can call as the leader. And that's what this particular union find algorithm do. It can merge your common data and then even it can find in every group a leader, right? Now let us see how can we apply this particular algorithm to solve this particular problem. In this problem, we initially have 26 different groups. We have some characters, right? In our base str, let us say the base str is BCD. Now this BCD belongs to none of these groups, right? Which we have created using S1 and S2. So what we will do, we will say, okay, if the input is, if the base str is BCD, the output is going to be B, C and D, because they doesn't belong to any group. So we will not do any kind of change in any of the character. So basically what you have is, we have initially 26 different groups and they are A, B, C up to Z. All the characters belong to separate or different groups. That is, there is a group in which there is a character A, there is another group character B, another group character C up to character Z. Now what you will do, you will merge few groups. Okay, let us say we need to form A and Z together. So we will merge A and we will merge Z together. So initially what you will do is, you will create an array for 26 characters. And for each of the characters, they belong to the separate group and that particular character is the current leader in that group. Now what does this statement mean is, you need to create an array. So that's our array. This is going to be our 26 length because we have 26 characters. So the indexes are going to be 0, 1, 2, 3 up to 25. And the values are going to be 0, 1, 2, 3 up to 25. I will tell you why. Initially, every element itself is a group, right? A, B, C, D, all are separate groups. And for every group, let us say A, the leader or the smallest character is A itself, right? Even if it is Z, the smallest character in this group is going to be Z, right? So what we are doing is we are creating an array of 26 length, and for each of the character we are going to store what is the group it belongs to and who is the parent or who is the leader of this group. Now there is a process to create this data and I will show you how. But for now what you need to do is you need to just create an array something like this, and this is your initial array of 26 character, and for each of the character they will belong to a separate group, and that character itself is the current leader in the group. This is our initial data. Now you can process the input S1 and S2, and based on the input, which is Parker and Morris in the example number 1, you will create groups out of this, right? For now they belong to separate groups. What you will do is you will merge the common data together, and then for each of the group you will have a leader. Let us see how we can do it. Now let us say P and M, that's at index number 0, right? We have the input Parker and Morris. At index 0 we have P and M. Now the thing is P and M belong to separate groups. We need to form a group in which the element will be P and M, right? How can we do it? The thing is they belong to the same group and M is smaller. So basically we want that for P, the parent or the leader is going to be M. In our array at index number 13, which is for M, the value is going to be 13 initially. At index number 16 it is going to be 16. This is for P. Now we need to group these together, right? What we are going to do is we are going to say, okay, let us group them together. And what is the smaller? Because we also need to make sure that we keep the parent or we keep the leader ready, right? So we will say, okay, M is the smaller. So I will say, okay, the parent of P is going to be M. So basically in your array at index number 16, the value is going to be 13. This is telling me that the index number 16 is for P. This is telling me that the parent of P is actually M. It means P and M belongs to the same group because ARR at index number 13, that is for M, is 13. ARR at index number 16, this is for P, this is also 13. So they belong to the same group, 13th and 16th character, which is M, and this one is P. And that's exactly what we need to do. We will process our S1 and S2 at each of the indexes, and for P and M or whatever is the character, we will mark them in the same group, and similarly we will process the remaining string. So what will happen is we will say, okay, the first characters are P and M. So in this case for P the parent is going to be M. For M the parent is already M. Then next is A and O. So what will happen, since A is smaller, so we are going to say for O the leader is or the parent is A. For A it is already A, right? The next characters are R, and for R the leader is already R, so nothing will happen in this case. The next is K and R. It means K and R will belong to the same group, so we will say, okay, for R the leader is going to be K, because for K the leader is already K, and for K and R we want the leader to be K, right? That is, they belong to the same group. Then we have E and I. E is the smaller, so for I, which is bigger, the parent or the leader is going to be E, so they will belong to the same group. Now next is R and S. Now this is very interesting to understand. Out of R and out of S, R is the smaller, so for S R is the parent, so for S R will be the parent. Now for R we have K as the parent. In base str we have S, right? So what will happen, we will say, okay, we will replace S with R, but we will ask one more question, that if we are replacing it with R, let us see, is R also being replaced with some other character? Yes, R is being replaced with K, so we will actually replace this S with K, right? And this is how this algorithm is going to work. Let me go through this base str and let me explain you. For P the value is M, so directly we will replace it with M. For A it is already A, right? For R it is K. For S the value is R, we will go to R. For R the value is not R, right? It is K, so we will actually replace it with K, because for K the value is K, so we don't need to just loop in further. For E the value is E, right? So if the value is E, we need to replace it with E, so we don't need to go further, because for E it is already E, for K it is already K, right? For R it is K, and for K it is already K, so we will replace R with K. And that's the whole concept of this algorithm and the problem itself. What we need to do is we just need to understand this algorithm union find, which merge common data, and for every group it will have a leader. Now let me show you the solution in Python, and everything is going to be very clear because the algorithm is actually very easy to implement as well. So let me so now this is the complete code in Python. I have created a new class which is union find. This class is going to implement the union find algorithm, and then we have this complete solution in our original class solution. So let me actually walk you through the solution. First of all, I am creating an object of union find class. So let me explain you how this union find class is working. Once you create an object in the union find class, there is this init function which is going to create an object, and in this init function I have created a variable self.parent. So basically an instance variable parent is created, and the value of this variable is a list which has 26 elements, and the values are 0, 1, 2, up to 25. We have two more functions, def find and def merge, and I will explain you what these functions are doing. But first of all, let us go through the code and let us see where are these functions actually used. Now we just run a simple loop in our S1 and S2. So since they have the same length, we will just zip them together, and the values are going to be I and J. Now I and J are actually characters, right? You need to convert these characters into indexes. So what I'm going to do is I'm going to find out the Unicode value of this particular character, and I will say whatever the Unicode value minus 97, because for A the value is 97. I am talking about lowercase character because in this input we are just dealing with lowercase character. So what this is going to do is, this is going to convert A into 0, B into 1, C into 2 and Z into 25. So we are just converting the characters into the indexes, because what we are doing is we are making use of 26 indexes for this, right? Now once we have the indexes ready, what we are going to say, data.merge, and that's very simple to understand. We just need to merge, or we just need to make these groups together. Now let us see how this merge is working. What this merge is doing is, it is saying that okay, for the given I and j, do the find. I is equal to self.find I, j is equal to self.find j. What this find is going to do is, this is actually going to find out who is the leader for this group, who is the leader of I, who is the leader of j. Now let us see with the example. The first character, now since we are running this loop, the first set of character in I and j are going to be p and m for the example number 1, right? Now what will happen is, this is going to do find. Okay, tell me who is the parent of I, which is p. So this is actually going to be p. Parent of p is p for now, and parent of m is m for now. How this find function is working, I will explain you, but first of all let's complete the merge function. Now let us say once you know the parents, what you are going to do is, you are going to say okay, let us see who has the higher value. Okay, if the value of I is more, what I will do is, I will say the parent of I is j now. That is, I is p, j is m. Now since this is true now, because p is more than m, so I will say the parent of p is actually m, because we need to find the lexicographically smallest string. Now let us say the question was about lexicographically largest string. Then in this particular case, we would have said okay, the parent of j, that is the parent of m, is going to be this value I, which is p for now. So right now we need to just find the smallest, so we can just change the parent of the largest character, which is p, and this is equal to m. If this is false, you just need to do the opposite. Parent of j will be I. Now how is this find function working? It is saying that if the self dot parent of this I is already I, that is, if parent of p is already p, then return the value p. So in this case we will get p, in this case we will get m. But later on we are updating the parent, and the parent of p is now m. Now let us say we run this function find, and the value of I is p. Then we will say okay, self dot parent of p, is it equal to p? No, it is not. Then what we will do, we will say okay, self dot find self dot parent of I, that is, find who is the parent of m, because right now the parent of p is m. Now find out who is the parent of m. So again this function is going to run, and it will say okay, the parent of m is actually m. So this will actually return m, and this will be returned again here, and then for p the output is going to be m. So this is how this function is working. This is going to find out who is the parent. This is going to do the merge, and then simple what we need to do is, after the merge is completed using s1 and s2, we will create a variable sol, which is going to be an empty string for now, and then we are going to say for every character in the base str, find out what is that index using the same logic. And then what you can do is, you can say okay, data.find of c, that is, find who is the parent of this character c plus 97, convert it back to the character, and then add it or append it in the sol. Once this is done, you can just return the value of sol, and this is going to be your final solution. So this is the complete solution class, and then this is the complete union find class, and that's the complete solution. You can just submit the code, and this is actually the best or the pretty efficient code for this particular problem. You can see the runtime is very good, the memory used is very good, so we have actually solved this particular problem. And now I think that's it for this video, guys. If you find this video helpful, if this video helped you to understand the problem and the solution approach as well as the thought process, then make sure that you hit that like button. And if you have not subscribed to the channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.